Welcome to the first lecture of Transistor series, and here we shall have a number of lectures because the concept of transistor is a very interesting thing, and the modern society is completely based on transistors. It's a beautiful device. In fact, it is the most important electronic device. Today's any electronic gadget is based on the concept of transistors. So in this lecture, the first lecture is basically the overview. So we shall have a general look on the transistors. So if we see that there are different types of transistors, unijunction transistor, which is called UJT. Then we have bipolar junction transistor, commonly known as BJT. There are two types, PNP and NPN. Then we have field effect transistor, FET, field effect transistors, and here we have two types. One is called JFET. JFET stands for junction field effect transistor, and we have MOSFET, metal oxide semiconductor field effect transistor. JFET, there is one type that is called depletion mode, and there we have two more types. One is N channel and another is P channel. In MOSFET we have two different types. One is called depletion mode, another is enhancement mode. Both the types we have again two types. One is P channel and N channel. Here also we have P channel and N channel. However, the discussion of UJT is the part of power electronics. Power electronics. Or we can say this is advanced electronics. FET is the part of discussion in intermediate level, analog electronics or electronic circuit 1. If you are electronics and communication engineering students, then you'll be studying this further, and thereafter you'll be studying on MOSFET in much more details. If you are interested in VLSI and nanotechnology, there this concept of MOSFET is very important, and today's modern ICs and everything is based on this, the concept of the MOSFET. But we are concentrating on basic electronics. So at the basic level we are interested in bipolar junction transistor. In most of the universities, basic electronics covers this bipolar junction transistor. So let us have a detailed look in bipolar junction transistor. So BJT, bipolar junction transistor, here the transistor, this term can be elaborated as transfer and resistor. Transfer of resistor. So during normal working, BJT transfers a weak signal from a low resistance input circuit to a high resistance output circuit. So that is why it is the term. Here, from here we have trans, here we have resistor. So together if we add them, we are getting this term transistor. Now BJT is a 3-terminal device, and here in BJT the flow of current due to the both electrons and holes. In our previous lectures of diode, we have learnt that in a PN junction diode we have minority charge carriers, majority charge carriers. So electrons and holes, these are the major charge carriers, and the flow of electricity is due to both for bipolar junction transistor. That is why this name bipolar is there. Both the polarity are present, positive and negative. Now as we have mentioned that BJT is a 3-terminal device. So these terminals are named as emitter, base, collector. So these are the 3 terminals of bipolar junction transistor. Emitter is generally white and heavily doped. So this doping concentration plays a very important role in the construction of bipolar junction transistor. So emitter has to be heavily doped. Then we have base. Base is a thin and lightly doped part of the transistor. Thin and lightly doped. And collector is slightly wider than emitter, but it is moderately doped. It is not heavily doped like emitter. So doping concentration is completely different for three different terminals. Now if we have a look at the transistor, PNP transistor, when you are calling PNP transistor, so here one N-type semiconductor is sandwiched between two P-type semiconductor. One N-type semiconductor is sandwiched between two P-type semiconductors, and here if we see that emitter terminal is heavily doped, so majority charge carriers in P-type semiconductor are holes, so hole concentration is quite high. For N-type semiconductor it is lightly doped and it is thin. So here you can see that the majority charge carrier here is electron. So electrons are less, free electrons are less. So since it is lightly doped, and it is moderately doped, so moderate presence of holes are there. Now we can see we have two junctions here, two PN junction here. So base to emitter junction, junction between base and emitter is called emitter junction. Base emitter base junction is also named as emitter junction, and in symbol we use J suffix E. Whereas for base to collector, this junction is called base collector junction or simply collector junction also, and denoted as JC. Similarly, for NPN transistor, here we can see a thin P-type semiconductor is sandwiched between two N-type semiconductors. A thin P-type semiconductor is sandwiched between two N-type semiconductors. Emitter is heavily doped, whereas collector is moderately doped, and base is lightly doped. And similar to PNP transistor, here also we have two PN junction. One is base emitter junction, which is denoted as JE, and base collector junction or collector base junction, that is denoted as JC. Now if we look at the symbol of the transistor, just like diode, we have the symbol for transistor. In fact, every electronic device is having some symbol. So if we have a look at the symbol of the transistor, so we can have this kind of symbol. This is base terminal, followed by collector and emitter, and if we see that arrow, there is one arrow from the emitter. Similarly, other type of transistor, we have the arrow pointing outside. For one type of semiconductor, the arrow is pointing towards base or towards in. For another type of semiconductor, arrow is pointing towards emitter. But for both the cases, the arrow is associated with the emitter terminal only. So do not get confused. Many a time students do make this mistake. They put the arrow with the collector. So please be careful here. So arrow pointing in, we call it PNP transistor. Arrow pointing out, it is the symbol of NPN transistor. This is a very important question even in interviews, and most of the cases we do confuse about the symbol of PNP transistor and NPN transistor. So I have a trick to remember it. Those who will get confused after a long gap, always try to remember this term, pointing in partner. So if you remember this pointing in partner, you see that PNP, pointing in partner. So that means arrow is pointing in. So this is the symbol of PNP transistor, and for NPN transistor not pointing in. So NPN, not pointing in, pointing in partner. So that is how you can remember the symbol of PNP transistor, and not pointing in is for NPN transistor. Now one important question, this is also interview question or in laboratory vivas. So if we connect two diodes back to back, will it work like a transistor? So answer is a big no. It will not work as a transistor. Why? First of all, the diodes available in the market, if you just simply connect them, definitely they will not work as a transistor because they are not in the same material. P, N and P both should be within the same wafer. We call this term wafer for the fabrication of transistor. Now second question, if we fabricate it within a single wafer, will it work? Then also answer is no. So if we look at the diode, PN junction diode, then P side and N side are of equal width and they are of same or similar type of concentration, impurity concentration. So here the impurity concentration and here these are same, similarly here and here. Now second thing is that this part, this is supposed to be the base part of transistor, because if we consider this N material which is sandwiched between two materials, so this is supposed to be the base material, base part. The width is quite high, so wider, this is much wider compared to two P regions, which is supposed to be say emitter, which is supposed to be the base, and this is supposed to be the collector. So this is quite wider, and from our previous discussion we have seen that base has to be very thin and lightly doped. So doping concentration is not matching. Similarly, width is also not matching. So as a result of that, this kind of configuration shall never work like a transistor. So now if we summarize this discussion, transistors are the most important devices in modern electronics. Entire nanotechnology, chip design, chip fabrication is revolving around the transistors. In bipolar junction transistor, the flow of current is due to the flow of both electrons and holes. BJT is a three-terminal device, emitter, base and collector. These three are the terminals of BJT. In NPN transistor, a P-type semiconductor is sandwiched between two N-type semiconductors, and in PNP transistor, here a small correction, this is N-type semiconductor is sandwiched between two P-type semiconductors. Okay, so this is a copy paste error. So previous one and this one, small difference is there. So PNP transistor, a N-type semiconductor is sandwiched between two P-type semiconductors, and NPN semiconductor, a P-type semiconductor is sandwiched between two N-type semiconductors. So that's about the overview of transistor. In next lecture we shall see the working of the transistor, NPN transistor, PNP transistor, and thereafter further topics we'll be discussing. So join me for the next lecture on the transistor series. Thank you.